Okay, guys. Good evening to you. I'm hoping that you guys are ready. How was your revisions? Hello? Anybody hearing me?
So repeat it on again here.
I'm asking, how was your revision?
Which revision, sir?
Say it again.
Which revision you're talking about, sir?
Which revision? You're not supposed to be revising. Exam will come up, you know? Exam will come up, so I'm supposed to always be revising. All right.
Now we got coursework,
Budget in expense, right?
You have coursework doing, you have other coursework doing.
no man, I touch much no one then come on. You have to left it.
Yeah, man. But just I look for one question here and I look for one question there and I look for one revision there. Makes a big difference. All right. All right. So we're on to differentiation. I want to be able to move a little faster. I'm behind. We missed 2 hours. I'm behind, and we missed 4 hours because I gave you 2 hours for the test, and we missed 2 hours on Tuesday of this week. So already I'm seeing us putting in a little extra class here and there to make up for some lost time. So I am behind now. I can tell you officially, I am behind. Um, so one of these days when I'm gonna say, hey, the plan come, one extra class. Do you have class on a Friday? Please say no.
Yes, sir.
Huh? Do you?
There we are web.
So I'm not hearing you.
No, no, we have web development.
Oh, yeah,
Six to
web
nine.
development.
Yeah.
Okay, got you. All right. Give me half a second, please. All right, so we were on to differentiation the last time. I am giving you another example on the product rule. First times the differentiation of the second, plus the second times the differentiation of the first. I'm going to ask that you just go through example 3 for me. I think we did 1 and 2 already. Go through example 3 for me, and I see a piece of my answer showing. But go to example 3 for me, and let us see how much you remember, because I'm moving into the other rules tonight. Are you all hearing me?
Yes, sir.
Okay, thank you. Obviously, are we finished?
So when you look on the previous example, no, so do it already.
Say it again.
I did that one already in class, you know.
I did that one in class already.
Yeah.
Okay, all right, no problem. And okay. So let's just move to the quotient rule then. Let us move to the quotient, or let me give you another example. All right. So this one here is going to be a little difficult. X minus 7 to the third power times 5x minus 7 to the third power times 2x minus 1 to the second power. Don't worry about this working out here. This working out right here is not correct because I just copied this a while ago. So start that one for me, please, as a recap to what it is that we've done before. Are you with me? I'm sorry, I'm not hearing anything. Are you with me?
Yes, sir.
Okay, thank you, sir. Obviously, there's no talk to no man.
So get the answer then.
Is that an answer?
And I can't recall it answer because they're big.
Okay. What should I call it then?
Trial and error. Anyways, let me tell
Trial and
you
error.
everything.
Let me hear what it sounds like.
Okay, so we get x outside the bracket 50x cubed minus 15x minus
We have
1372.
Whoa, that's so no, but
You see it. Alright.
all right. Anybody else agree with Chev?
Sir, I'm not really finished, but I didn't do the outside the bracket part, but I got 50x minus 43.
All right. I give you 2 more minutes for you to try and get that. 2 more minutes.
Recording in progress.
All right. You guys have a coursework piece working on tonight, or a coursework test or something? I'm not getting the energy from you guys at all tonight.
Sir, we have a couple.
Yeah, but I kind of want to hear from you guys. I'm speaking. I'm only hearing the. No, I'm hearing you, but Chev is the one that has been talking to me for the whole class. If you're working on another piece of assignment, no, I'm just going to ask you to pause. It is easier for me to teach and give you and dismiss you early, so you can spend some more time on the assignment or what it is that you're doing, than for me to be struggling because I'm going to be teaching, you're not going to be understanding, and I'm not going to have the time to go through again. So I'm going to answer your undivided please. I'm not getting the energy from you guys at all tonight. Right? So let's go. So it's the first times the differentiation of the second plus the second times the differentiation of the first. So it's the first times the differentiation of the second the first times the differentiation of the second times the two x minus 1 to the first, 2 times x minus 1 to the first, minus 2. So the first times the differentiation of the second plus the second times the differentiation of the first 5x minus 7 to the second. All right, so look and see if you agree with this piece here. Is the first 5x minus 7 to the third times the differentiation of the second. When I differentiate second, I'm going to get 2 times 2x minus 1 to the first times 2 plus the second. Times the differentiation of the first 3 times 5x minus 7. All right. Tell me, I'm going to reproject something. I'm just trying to be consistent with my color code. Tell me if you agree with the differentiation in blue.
So the times it by 2 again.
Which two are you talking about? This one right here?
Yes, sir, that one.
Right. I know I kind of suspect that. Remember, it's the first 5x plus 5x minus 7 to the third. The first times the differentiation of the second. So let us differentiate the second. This 2 here, the power is being multiplied in front of, which is this 2. All right?
Yes, sir.
Time, so it's that 2, and then I'm going to say 2x minus 1 to the first because I'm reducing it by 1. And then I have to differentiate what is on the inside of the parenthesis. So this 2 is the differential of what is on the inside. Follow me, Chef?
Oh, all right.
Yeah, and then plus the second times the differentiation of the first is 3 times 5x minus 7 to the second times 5. Yeah. Let me do something here. So it's going to be, let me just I'm just trying to check my solution. All right, so you did something, Chevy, that I need to talk about. But I just won't tell you at what point we need to talk about it. Okay. This one. Alright, so it's gonna be 4 times that 5x plus 15 times the log. All right, tell me if you agree with the two black lines. I'm factoring at this point. I'm looking to see what is common here, that is common there. And I recognize that 5x minus 7 and 2x minus 1 is common to both. So I remember I'm taking out the smaller of the two. So I have a 5x minus 7 to the third on this side and a 5x minus 7 to the second on this side. So I can only take the two of them because I have to take the smaller of the two. And on this side, I have 2x minus 1, but on this side, I have 2x minus 1 all squared. So I can only take out 2x minus 1. 4, there's no common factor between 4 and 15, so the 4 remains here. When I multiply all of this now by what is here, I will end up with my 5x with the 4, of course, the 2x minus 1. And this now is 5x minus 7 to the third. Okay, so that is correct. 15. Oh, this 4 is not supposed to be there. That 4 on the outside, not supposed to be there. So I'm going to have 15, 5x minus 7 squared, 2x minus 1 squared. All right, that looks correct to me. Look to see if you agree with that line. Look to see if you agree with the second black line. I'm in agreement with the blue and the two black. I need to just wrap it up right here in terms of tidying up what is in the square parentheses. But you look at it first though. Oliver?
Yes, even.
I'm not getting no support from me tonight, man. What go on?
When I pay up now, lift up something man when I feel so 100.
Oh, careful, man. All right, so let me just wrap up this one then. Let me just wrap up this one, so you know. Four five 20, that's 28. 4 7 is 28. 15 times 2 is 30, that's 30x minus 15. 4 5 20, 20x, 4 7 is 28. 15 times 2 is 30. 20 plus 30 is 50. And 28 minus 15 is 30, 43. All right, take a minute or two to look at that for me. I'm going to give you a minute. I'm going to step away for 2 seconds. I'll take a minute or two and look at that. Check to see if I've been an error with the stop. I'm going to come back to you, Chevy, because you're telling me some big numbers, and I want you to look to see where you went wrong, or if I went wrong. Give me half a second. Wait, look.
I go and scan CMA, sir. I go and scan there.
All right, good. All right, I give you another 2 minutes. One day thing.
So, sir.
Or you still know?
All right, sir. Sir, so something there, sir. The question them can get more difficult on this.
It wouldn't. It wouldn't. It can. But it wouldn't. So it wouldn't. But I want to find out though where you got you say you got something like 15,000 or something. What did you do? You expand out everything?
Well, sir, man, we get rid of the pause and so I
Oh
put
no.
them inside
Mm-mm.
the bracket.
No.
Inside the bracket.
Yeah. So a rule of thumb: never, ever, 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 ever try to expand those parentheses. Listen to me, man. It's nice and nice because them can give you something to the fifth power, right?
For
Um,
real.
Yeah, man. So you wouldn't want to go and do that. Just what the method that you see me employ here by just factoring out. That's what I want you to do. Just go ahead and factor out, and you should be fine. Factor out and you should be fine. But do you agree with what I have on board?
Yeah, man.
All right. So let me jump now. Simon, how you stay?
Yes, sir, I'm fine. I got the 50x minus 43 ready, but everything else I didn't get it.
But are you seeing how I got it? No?
Yes, sir, I seen it.
Good. All right, Oliver, why stay in one position? But can you put the screen in front of you, Oliver, and see if you're following what is happening?
No, I'm not follow what's happening so far.
Nice, nice. No matter if you don't have to write to put yourself into any further pain, I can understand. But just watch along. You'll have the recording and I will send you the stuff. So just try and be comfortable, but try and participate.
Thank you very much.
Easy. All right, now, so the quotient rule. I have to jump to the quotient rule. The quotient rule said the denominator times the differential of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. So it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. Just like how we did the product rule and said the first times the differentiation of the second plus the second times the differentiation of the first. The quotient rule is the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. You do that, you can't get the question wrong. So let us look at an example. My example here is y equals x squared over x plus 2. Y equals x squared over x plus 2. Y equals x squared over x plus 2. The denominator, once I call it, I write it back. Once I call it, I write it back. The denominator, x plus 2, see it here, so, times the differentiation of the numerator. When I differentiate x squared, I get 2x, see it here, times 2x. So it's the denominator times the differentiation of the numerator minus the numerator, so it's minus x squared, see it here, minus x squared, times the differentiation of the denominator. When I differentiate x, I get 1. When I differentiate plus 2, a constant, I get 0, so it's just going to be 1, see it here, times 1. All over the denominator square, x plus 2 all squared. So the differentiation really ends right here. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. The differentiation ends right there. If you sing the song and write it, you're good to go. You can't go wrong. You sing the song and you write it, you can't go wrong. I promise you. It's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. All I'm doing, Chevy, never, ever, ever try to expand the denominator in this case. You're going to leave it as it is with the powers. The only thing you can do if something is common, you can factor it out. But otherwise, we not touch it. We not touch it.
And that's what I'm telling you, try and everything else.
Come on, no man, and I appreciate it, but I appreciate it, man. I appreciate it very much. But I'm just saying to you, just overemphasizing. Don't you ever, any one of you, try to expand the denominator. You get run into problems. So if you look at it, you recognize that my denominator is written back every single time. See, every single time in the final answer, every single time. All I'm going to be doing now is just work up the numerator. So this is x plus 2 times 2x. So it's 2x times x is 2x squared. Oh, what I did, I did a rearrangement. I didn't have to do this, but because it was the first example, I showed you that I can put in the 2x in front of the x plus 2. So 2x times x is going to be 2x squared. 2x times 2 is going to be 4x, see here. And then now minus x squared times 1 is minus x squared. When I group together now, I'm going to have 2x squared minus x squared is just simply x squared plus 4x. So I can either leave my answer here in blue, or I can simplify it and leave it here in red. Are there any questions? Look at it. Don't answer me yet. Look at it, and then ask me your questions.
No, I don't have no questions.
You don't have a question with that. All right. Simon, where you say, Papa?
Sir, the 2x in the second y,
This one?
the one above that.
This one
Yeah,
here?
the 2x. Yeah, that's sir.
All right. So it's the denominator, x plus 2. Remember, the denominator times the differential of the numerator minus the numerator times the differential of the denominator all over the denominator square. So watch me now. The denominator, see here? The denominator is x plus 2. So I write by the x plus 2 times the differentiation of the numerator. When I differentiate x squared, I'm going to get 2x. So this is the differential of the numerator. See here? It says I'm supposed to times it by the differential of the numerator. And then I must minus it now. Minus the numerator. So I get minus x squared, because that's the numerator. See here? Minus x squared. And it says now times the differential of the denominator. So I'm going to differentiate x plus 2. When I differentiate x plus 2, I get 1. So times this one. And then everything is all over the denominator square. So I'm going to put everything over x plus 2 square. So this 2x is going to come from the differential of the numerator.
All right, sir.
Cool. Oliver, are you still, it look good?
Yeah, man, yeah, man.
All right.
Numerator, denominator, then as I said, I like what you mentioned too, so we have to try expand
The denominator,
yeah.
yeah, man, make it say, I trouble that. Make that say, not trouble that one day. All right. I'm going to give you, I'm trying to leave the example one on screen. You have another function, x squared. Of course, you know that once you're using the quotient rule, it must be a fraction. It must be a fraction, numerator, denominator, in order for you to apply the quotient rule. All right? So you have another quotient, y equals x squared minus 3 over x minus 7. I want you to differentiate that for me, please. I give you 2 minutes. Always stay.
And
I'm get the answer x squared minus 4x minus 3 over x minus 7 to the second. I'm
That
get
again?
minus 3. Hold on a second. I'm gonna get minus 3. I'm gonna get minus 3.
You remember there's a minus sign in between, you know.
Yes, yeah. Uh,
So when you multiply this minus sign by this minus sign, you get a positive 3.
yeah, for real.
Simon, how you stay?
Sir, I saw where I went wrong. I did in the top line again, the 2x. I ended up doing 7x. But I see how it is now.
Okay. Oliver, when I leave you out, you know, you're looking at what we do right here. Let me just run through this quickly so that they can see it all about the denominator, boom, times the differentiation of the numerator. So I'm differentiating the numerator. This is a constant -3. So when I differentiate the numerator, I'm going to get 2x. See clear so? Minus the numerator, so again, minus all of x squared minus 3. But because the numerator is more than one term, I'll have to contain it in a parentheses. All right, so I just put it in parentheses. I can't just put it as minus x squared minus 3 because this negative sign is going to also govern this this -3. All over times the differentiation of the denominator. And when I differentiate the denominator, I'm going to get 1. So this is the 1 for the denominator. All over the denominator square. And the denominator square is going to be x minus 7 all square. The x minus 7 all square remains. That not change. Then I'm going to distribute this. X times 2x is going to be 2x squared. And negative 7 times 2x is negative 14x. And then negative 1 times x squared is a negative 1x. And negative 1 times negative 3 is a positive 3. And the x squares can be merged. So it's going to be 2x squared minus x squared is just simply x squared. There's only one negative 14x and a positive 3, so I write it back, and that's the end of the question. See that, Oliver?
Yes, let's see.
Nice. All right, so we're getting sharper. We're getting sharper. Yeah, there goes another one. Start from me, please. How we stay?
All right, so I'm get the answer this trip here.
Huh. All right. Let me hear it. Let me hear your answer.
4x squared minus 40 plus 4x minus 2x minus 6. 2x minus 6 in bracket. To the second part, all the x squared minus 7 squared.
You know, so one of the last part, me agree with you on one.
What one is that?
I have a clue. I have no clue. I don't know what I did right here. Hold on, then. The denominator. Oh, so the denominator is x squared. Oh, so the question got a little difficult. So it's the denominator, x squared minus 7, times the differentiation of the numerator. So it's going to be 2 times x minus 3 times the differentiation of what is on the inside. Are you differentiating what is on the inside? Because it's important to know.
Yes, sir,
Remember the power.
reach.
You got that?
Wait.
Unstable.
Wait, so oh, you get one yes and no, sir.
Because I'm differentiating what is on the inside of the parentheses times the differentiation of the inside, and the differential of x is going to be 1. And then minus the numerator, minus x minus 3 all squares, times the differentiation of the denominator, which is going to be 2x. So the differentiation ends right there, saying blue. Differentiation ends right there in blue. Look at it. I give you a couple minutes again to look at it, and then we'll talk more about it. Obviously, talk to me. Obviously,
Alright, sir. So let's see what's going on now.
all right, so you see what is happening, right?
Yeah, man.
So put it this way. I really have not changed up any other variables on the. It's just that, and the question may look a little difficult, but guess what? It's the same methodology that we're employing every single time. The same methodology. What's the methodology? The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squared. Same thing. But you just have to be very specific with the differentiation. You just have to be very specific with the differentiation. And once you're specific with it, and you get that line in blue, differentiation is right there now. All you have to do now is to employ your algebraic skills. Get your algebra out of the way, and you're good to go. I promise you. That's all that needs to be done. Get the algebra out of the way, and you're good to go. All right. Let us try one more. It is important that we do. We understand the differentiation to the maths, because the next topic that you're going to see on screen, maybe not tonight, but for sure soon, is going to be something that is going to involve applications to differentiation. All right. So let us try another one. So one there, try that one for me, please.
How we still finish or still working?
Still working, sir. Still
All right,
working.
cool. All right, cool.
How we still know?
All right, so let me get an answer.
Mhm.
X minus 32 cube plus x minus 3 squared minus 5x plus 27 all over x minus 7 to the 5th.
I don't know how it is that you.
I eat that now, sir. That needs some rest.
Hmm?
Servants, I eat that B9, you know, sir. That needs some rest.
I don't. I mean, I love the effort, you know. Really and truly, I love the effort. Let us walk through this one step by step. And as I walk through step by step, look to see what you have done. And we'll compare answers. So it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. All right, so let's go. The denominator right here times the differentiation of the numerator. So I'm differentiating the numerator. So it's going to be 2, see it right here, so, times x minus 3, and I reduce this by 1. So you come to the first power, see it right here. You're not seeing the first power, but you know that it's the first power. And then I'm timesing it by the differential of the inside. When I differentiate x minus 3, I'm going to get 1. Let me know if you agree with that.
Reach there, sir.
Good. Minus the numerator, minus the x minus 3 all squares. Now we're going to times it by the differentiation of the denominator. This is going to be 3 times x minus 7 to the second. See here? 3 times x minus 7 to the second. Now we're going to differentiate what is on the inside of the parentheses. Differentiating what is on the inside is going to be 1. See the 1 here? All over the denominator square. It says x minus 7 cube square. Not because this is already raised to a power, mean that we're not going to raise it to the second power. It's still going to be raised to the second power. So it's going to be x minus 7 cube all square. Now, when this is the powers looking like this, we are going to be multiplying these two powers. 3 times 2, 6 to give us 6. So a to the m raised to the nth power is a to the mn. So we're going to multiply the 3 times the 2 to give us 6. So we're going to work out the numerator now. 2 times 1 is 2. X minus 7 cubed, see here, x minus 7 cubed, and the x minus 3 is right here. 3 times 1 is 3, so there's 3 here. X minus 3 squared times x minus 7 squared, see it right here. So I have somewhat reduced it to make it look a little nicer. Then now we're factoring. So remember, we're removing the smaller of the two every time. So we recognize that the x minus 7 and the x minus 3 are common to this side of the negative sign and this side of the negative sign. But we're taking out the smaller of the two. So x minus 3 to the first and x minus 3 to the second. That means we can only take out x minus 3 to the first. See it right here, so boom. And we have x minus 7 to the third, and we have x minus 7 to the second. We can only take out x minus 7 to the second. See here, boom. And there's nothing common between 2 and 3, so we're going to leave those alone. Then we're going to draw our square parentheses. And when we draw the parentheses now, we're going to see if we can get back our top here. What do I multiply by x minus 7 square times x minus 3 to give me all of here? And now I need a 2. And we need 1 more of the x minus 7. See it here? 1 more of the x minus 7, because the x minus 3 is to the first power, and we'll have it to the first power here. Then we're looking to see what we want here. We definitely need a 3. So we're at the minus 3. And we have 1 of the x minus 3. So we're going to need 1 more because it's 2 we have. So we're going to need 1 more. And we have the same number of the x minus 7. So all I need to do here now is to simplify this. 2 times x is 2x. 2 times negative 7 is negative 14. And negative 3 times x is negative 3x. And negative 3 times 3 is positive 9. Grouping my like terms, I'm going to have 2x minus 3x is going to be minus x. And negative 14 plus 9 is negative 5. And then, oh, so this is what I was saying to you. We're not going to trouble anything with the denominator unless something can cancel out. You see what I have here? I have all of this here, and I recognize that, oh, but this is x minus 7 to the second power. But I have x minus 7 to the sixth power. So all of this up here can cancel into this and leave 4 of them. So that's why I'm going to have x minus 7 to the fourth power here. And then this is just x minus 3 times negative x minus 5.
Hold on this, go back up a little. All right, now, sir. So that x minus 3 to the second, what do I do with it?
This one here?
Yes, sir.
Good. So I'm factoring out the smaller of the two. So when I multiply this x minus 3 outside of the parentheses with this x minus 3 inside the parentheses, I'll divide the x minus 3 all squared. You follow me? I'm factorizing here, you know. So please know that we are factorizing.
Oh, yeah.
So we're factorizing the numerator. Very important. Because what we're doing is just simplifying this stuff, you know. The differentiation ends from up here, you know. The differentiation ends from up here. Get a couple marks well up here. It's just a simplification that we have to do with now down here. And based on what it is that you're saying to me, it sounds like you got the differentiation part correct. True or false?
Yeah, I can get it right, yes.
It's just a little algebra killing you.
Big algebra, that, sir.
Yeah. I'm Simon, how you stay?
Sir,
Half asleep,
yeah,
down.
sir, I'm still looking.
What say you do?
Sir, is a lot.
It is. It is. It is. It is. It is. But remember, this is calculus 1. All right, do me a favor. I'm going to let this stay a little longer for you to look at it, and we're just going to do one diggy one more, just one more, and then we'll call it a night. I don't want to call it off just yet. I don't want to call it off just yet. I know you guys tired. I know it's raining and you want to go sleep. Just one diggy one more, and then but I want you to digest this one first, though. So if you have to take it off, go ahead and take it off. And then in another minute or two, I'll give you the last one to do for me in class. All right?
All right, sir.
Restroom break.
All right, cool. Ready for the last one now?
Yes, man.
Cool. Number 5. Finish this one now?
Yes, sir. Get the answer.
Read it out.
4x squared minus 8x plus 5 over x minus 1 squared.
Or if you don't forget the last one right.
So another one them right.
Hmm?
So the one they right, sir, but I talk about the one them with the square, you know?
Yeah.
The one them with the powers outside.
The powers
bracket.
right. So that's what so clearly the power rule, you need to sharpen up the skills on the power rule. You need to sharpen those skills on the power rule. All right. So Simon, what do you say?
Yes, sir. Sir, you're going to send the notes.
You want me to send it tonight?
Yeah, you can send it tonight or tomorrow.
All right. All right. We'll do for you. All right. I'll send that off tonight. Oliver, how you stay? You all right? All right. Oliver, drop asleep. All right. So I'll call it a night here tonight. I'm gonna fix up this notes and send it off tonight for you guys. But please remember, guys, you have to practice. You must practice. If you don't practice, you're gonna be in problems. And already you see, Chev recognized some of the ones that giving him problem. Them straightforward when you're in box it off, right? So we all know what we need to work on, our strengths and our weaknesses. So I'm gonna ask that you just do some work for me, please, and thanks. All right?
Yes, sir.
Sir.
All right. Big up on yourself. Later.